Hello students, welcome to Educate. In the last videos, we have discussed about standard electrode potential. In this video, we will discuss from magnetic properties of the transition metals. Okay, so let's see. Already know that the compounds can be diamagnetic or paramagnetic. There is two types of magnetic substance. One is diamagnetic and another one is paramagnetic. And I think you have already aware about ferromagnetic. That means there is three types of ferromagnetism, which is the extreme case of paramagnetic. Ferromagnetism is the extreme case of paramagnetism. How we predict? Let's see here. What is diamagnetic substance, paramagnetic substance, and ferromagnetic substance? In the NEET exam, in the IIT main examination, there was a question. That means 4 years before. Question was asked: which of the following substance will repel when magnetic field will apply across the substance? So, if you will tends to mug up these substances, then you could not solve the question. So, main here you have to understand the concept. So, firstly, what is diamagnetic substance, paramagnetic substance, and ferromagnetic substance, and how to predict? What is paramagnetic? Firstly, diamagnetic substance. This substance which repelled by the magnetic field. That means here magnetic field will apply across. You know about the magnet, and common known magnet is bar magnet, North Pole, South Pole, in which one. So, what is paramagnetic substance? Firstly, diamagnetic substance. This substance which will repel from the magnetic field. That will be called diamagnetic substance. Diamagnetic substance. Diamagnetic substance, it will repel by magnetic field. So, diamagnetic substance repelled by the magnetic field. And how to predict? The substance is diamagnetic or paramagnetic or ferromagnetic. So, diamagnetic substance which will repel by the magnetic field, and the substance which don't contain unpaired electron. Don't contain unpaired. So, the substance which don't contain unpaired electron, that will be diamagnetic substance. Now, very important, that was a question of BHU, Banaras Hindu University, of the 2003 or 4. That was the question, that which of the following substance is diamagnetic. And one of them is, in the option, there will be O2 also. Here I am telling you, so you be careful. When you will draw the Lewis-Norton structure of O2, you will find out that there will be no any unpaired electron. So, what you think? You will think that it's a diamagnetic substance. But actually not. It is paramagnetic. And how is it paramagnetic? That has been explained by molecular, that means various theories of the chemical bonding. And that was about the molecular orbital theory, one of them. So, about the paramagnetic behavior, of dioxygen, molecular orbital theory has explained. That has been explained by molecular orbital theory. Okay, so here diamagnetic substance not only in that will not only apply in this chapter, even though in any part of the chemistry. So, a substance will be diamagnetic if that will not contain unpaired electron. Okay. Now, paramagnetic behavior. So, obviously that will attract it towards the magnetic field. Paramagnetic substance will weakly attract towards the magnetic field, and ferromagnetic substance that will strongly attract towards the magnetic field. Diamagnetic substance repelled by the magnetic field, paramagnetic substance that will weakly attract towards the magnetic field, and ferromagnetic substance will strongly attract towards the magnetic field. Okay, so diamagnetic substance don't contain unpaired electron, paramagnetic substance contain one or two unpaired electron, and ferromagnetic substance contain a number of unpaired electron. That is about. So now let's see here the magnetic subproperties. But here, that is the most for the ferromagnetic substance. That's the in most of the cases happen. But what happened? I tell you something which is not in this book, but that is quite important for your main examination. So what is that? Not only the presence of the unpaired electron is sufficient. Most probably that will be paramagnetic. But what is here? There is a domain. Suppose this side and this side. Direction of domain is this side and this side. So during that course, the dipole moment of one domain cancel out that of the other domain. Okay, I shall discuss about this point, which in the videos which will be made for exclusively for the IIT main examination as well as NEET examination, because what you will have to study for the IIT examination, that you will have to also study for the NEET examination. Yes, I am telling you frankly, which usually teachers don't tell, because they will induce you study more. Okay, I also want that you study more and more you study. I want you study those points. You study those points which will be helpful for you to solve the questions in the IIT main examination, advanced examination as well as in NEET examination. So I am telling you here, that means there be some concepts from here. There are some few types of questions which usually do ask in the IIT main examination, the IIT advanced examination, but not in NEET examination. In the same way, there are few questions which usually ask in NEET examination, but not in IIT main examination as well as in IIT advanced examination. Okay, so but where that will be, and I think if you have watched my video continuously, then you might have realized that I inform you that this one is more important for which examination, that is for 12th board examination, for IIT main examination, for IIT advanced examination, or for NEET examination, or for the CUET examination. I usually informs. So there also I shall inform you that which one is more important. So for whom that will I said say that is more important. So that concepts will have to revise to those students who are preparing for that particular examination. Like when I am telling you that this one is very important for 12th board examination, then the students who is preparing for 12th board examination, he will have to watch that points a number of times, okay, as possible as more and more number of times. Okay, now let's see. So how to find out the dipole moment of electron. So dipole moment of the electron, that is represented by here formula also given, root under n into n plus 2. Here n is number of unpaired electron, n is number of unpaired electron, and the unit of dipole moment, this one is Bohr magneton, BRM here, simply we write BM, Bohr magneton here also written. So unit of this dipole moment is Bohr magneton. Okay, now let's see. That was about the magnetic behavior, and here just calculated and observe what is that. You might have, you can watch out very easily, and when you will find out, then you may realize that there will be only bigger difference between the calculated value and the observed value. There will be bigger difference here between the calculated value and that of the observed value. So very easily you can do that question. Okay, and no need to mug up what's the value of calculated value and what's the value of observed value. No need to mug up. In the examination, question will not ask what is the dipole moment of suppose Mn2 plus. In the examination, question will not ask. Okay, and if you will have to find out, so you can find out very easily by the electronic configuration. So like manganese, there is 5 unpaired electron. So root under, to do that, 5 into 5 plus 2, that is 7. 5 into 7, 35. Root under 35, how much you can find out here. Okay. Now let's watch out this question. Calculate the magnetic moment of a divalent ion in aqueous solution if its atomic number is 25. Listen here, atomic number is 25. Any element that is actually for manganese given here. Manganese atomic number is 25. If you know, that's it's okay. If you don't know, then also doesn't matter here. So atomic number is 25. So when you will write the electronic configuration, that will be 3d5 4s2. That is here. That is the electronic configuration of that element in +2 oxidation state. It's 2 electron we release from 4s. Okay. Okay. Now few students do the mistake. What did he do? That there is 2 positive charge, so he decreases the atomic number by 2. No, will not have to do, because might be you will do the writing the electronic configuration like 3d5 later on and 4s2. So keep in the mind that the last electron enters in 3d, but when electron will have to lose, then that will lose from 4s. A number of times I have informed you. So electronic configuration will be here for Mn2 plus will be 35, this one. So now number of unpaired electron is 5, n is 5. So dipole moment will be root under 5 into 5 plus 2. That means that much Bohr magneton. Its unit will be dipole moment Bohr magneton. This one. Now that will be 5 to 7, 7 into 5. That means 5 into 7. That is root under 35. Root under 35. 6 is a 36. So something less than 5. So 5.9892 like that here. So 5.92. That much Bohr magneton. That is here. So that's why this came. Okay. In the probability of asking this question is more in 12th board examination as well as in NEET examination. But in IIT main examination, direct question will not ask. Yes, that will be helpful to solve the questions. This concept will be useful to solve some other questions in which there will be requirement of a number of unpaired electrons. But direct question will not usually, there is less chances of asking in IIT main examination. So the students who is preparing for the 12th board examination as well as for NEET examination, solve that question carefully, and that question is too much easy. Now same here, calculate spin only magnetic moment of M2 plus ion, Z equal to 27. Very easy, you can do, but even though I am telling you here, listen. But whole calculation I shall not do. Atomic number is 27. So there is a metal. Actually it is for cobalt. Cobalt atomic number 27. So let's see. Only suppose if you don't know, then M27 electronic configuration. (3d7 4s2) here. Okay, divalent ion. So here electron will lose from 4s. So now the electronic configuration will be same here. Oh, suppose no, 3d7 here. So dipole moment, that will be equal to root under 7 into 7 plus 2. Root under 63. 8 8 is 64. So 7 point that much Bohr magneton unit will be that much Bohr magneton. 7 7 ja 8 8 ja 64. So something less than 8. So 7.9 or like that. This one Bohr magneton. So watch out in the option in the examination of NEET examination. You just watch out the option in which their value is near about 7.9. That means something more than 7.9. So tick on that. Okay. So based on the option, you can save your time also. And in a 12th board examination, simply you did there, and you will not have that scarcity of time. You will have ample time to solve that question. Now let's see here. Formation of colored ions. Why that compound so colored? Okay, that means here a number of times in 12th board examination question was asked that the one is the transition metals show color. Why? Or the complex compound why shows color. Okay, so let's see here what actually is. Before that, I have also do that concept that the degeneracy of d orbitals that don't maintain for a longer time period. This is d orbital, here dxy, dyz, dxz, dx square minus y square, and this is dz square. Might be recall that. So what happened? The degeneracy of this d orbital do not maintain for a longer period of time. The energy of dxy, dyz, and this dxz that decreases, and that is called T2g energy level. It is called T2g energy level. And the energy of this dx square minus y square and dz square, the energy of this dx square minus y square and this dz square, that increases. So the degeneracy of d orbital means the orbitals having same energy. This or all these 5 orbitals are degenerate orbitals, means the energy of all these 5 orbitals will be same. So but that don't maintain in case of d block elements, that don't degeneracy do not maintain, and that splits into T2g energy level and EG energy level. It is called EG energy level. T2g energy level and EG energy level. When light falls on the compounds of transition metals, then the electron present in then the d block elements will absorb some amount of light, and the electron present in T2g energy level that will jump into EG energy level, and the remaining portion of light will reflect back. You know already the light is composed of 7 colors. Vibgyor might be that means I hope all of them know very well that light is, there is 7 component of light, and when the visible light falls on the compounds of transition metals, then some of the energy absorbed by the electron present in T2g energy level, and the remaining portion and jumps into EG energy level. The remaining portion of light will emit by the compound, and that will have a particular color. Okay, that's the reason. So in 12th board examination, question asked why the transition metals show color. So you will have to write that the degeneracy of d orbital do not maintain when light energy falls on the coordinate compounds. Then the electron present in T2g energy level will absorb some amount of light energy and jumps into EG energy level, and the remaining portion of visible light will reflect back, which will falls in a particular color, and that's why the d block elements, the compounds of d block shows color. Okay, now let's see next. Formation of complex compounds. What is complex compound? Firstly, so complex compound, as the name indicates, complex. What actually here? Actually, the study of those few compounds was difficult. about the study of few compounds was difficult. So those compounds were called complex compounds. But as the time proceeds, the study of those compounds also became easier. So now that will be unjustifiable to tell them the complex compound. Now they are called coordination compound. So what is here coordination compound? So coordination compound that is defined as the compounds which shows two types of valency. The compounds which shows two types of valency. One is called primary valency and the another one is called secondary valency. The primary valency satisfies through ionic bond and the secondary valency satisfies through covalent bond. Therefore, the primary valency will be ionizable and the secondary valency will be non-ionizable. That is coordination compound. The compounds in which a central atom shows two types of valency, that is primary valency and the secondary valency, of which the primary valency satisfies through ionic bond and the secondary valency satisfies through covalent bond, and therefore the primary valency are ionizable and the secondary valency is non-ionizable. So let's see here, as for example here PtCl4 2 minus. Actually a structure might be like this, K2 PtCl4. This is actually Cl2 minus. Here minus charge means some cation, any cation is attached there. Suppose here this compound here is positive charge, that means some anion has been attached there. So that compound may be CuNH3 whole 4 and SO4, or that may be also CuNH3 whole 4 Cl2. That is, so compound may be this one, and here this PtCl4 2 minus, that means here potassium or sodium, any cation is getting bonded there. This one. So what actually here, when you consider about this one, so here bonding between platinum and chloride ion, the bonding between platinum ion and the chloride ion is covalent. This bond is covalent, and this potassium will be electrostatically bonded to whole of this compound. So this bonding, that means the between potassium and this whole of this one, that will be satisfied through ionic bond. When this compound will get dissolved in water, suppose you dissolve this compound in water. So what happens? Here is potassium is getting bonded to this whole compound. So potassium will get separate from this portion. So there was 2 potassium, so 2 moles of K plus, and the remaining portion will appear to the remaining portion, 2 negative charge will appear there. So that is here bonding between this potassium, that means cation, and the whole of this one, which is called coordination sphere, that is ionic, and this bonding is covalent, that means between platinum and that of the chloride ion, that will be covalent bonding. Okay, so that's why bonding between platinum and chloride will not dissociate. When you will dissolve, this compound will be dissolved in water, then bonding between platinum and that of the chloride ion will not dissociate, but the bonding between the potassium and whole of this sphere, that will get dissociate. Okay, same here for sodium, this one very easily, that will be wastage of time if I shall tell you. Same here. Now same here in this compound, the bonding between copper and that of the ammonia, that will satisfy through covalent bond. So here this will be covalent bonding here, and the sulfate ion or the 2 chloride ion, that will be bonded to this whole this portion through electrostatic force of attraction. So bonding between this whole sphere and that of the sulfate ion, that will be bonded through here ionic bonding. So that's why when you will dissolve this compound, then this whole sphere will get separate from the sulfate ion. So sulfate ion will get separate, that become SO4 minus, and the remaining portion, there will be development of positive charge. So 2 unit positive charge here. That's the reason that is has shown here. Okay, for this compound and for this compound, this one. Okay, I hope this is clear. But in the question, 12th board question, question will not ask explain this one as I have explained. Question will ask why the D block elements form complex compound. Why the D block elements form complex compound. So what happened here in the D block elements? In case of D block elements, there be incomplete d orbital. In case of D block element, there will be presence of incomplete d orbital. So in that incomplete d orbital, some molecules or ions, some molecules containing lone pair of electron or the ions donate their electron and bond it to the central atom through covalent bond. Since the d block elements contain incomplete d orbital, in which the molecule containing lone pair of electron or the ion donate their electron and bond it to the d block element or d block metal or the transition metal, what will be the question, will then the molecule or the ion will be bonded to the d block element through covalent bonding, and hence the d block elements show color. Okay, one thing also, there is some metals also which is not transition but that shows color. As for example, magnesium, that is not a transition metals. Magnesium, that is alkaline earth metals. You know already, magnesium is alkaline earth metals, but there is presence of vacant d orbital, and here there is presence of vacant d orbital, and that's why it also forms coordination compound. And the very well known example is chlorophyll. Chlorophyll contain the magnesium compounds of magnesium, coordination compound of magnesium. Okay, that is here why the d block elements forms complex compound due to presence of incomplete d orbital. Okay, so if you will write due to presence of incomplete d orbital, then also you will get full marks. So main here keyword is presence of incomplete d orbital. That was this one. Next one is catalytic properties. What is catalyst? In the chapter of chemical kinetics, you have studied very well. What is catalyst? So catalyst is, so I am repeating here, what is catalyst? Catalyst is the chemical substance. Catalyst is the chemical substance which increases the rate of reaction. Here it has been shown what is the catalyst here, like that. And how the catalyst increases the rate of reaction. Recall that. If not recalling, then watch the video of chemical kinetics once again. Now let's see here. There is a reaction in which I minus react with thiosulfate ion. Oh, sorry, persulfate ion. Okay, so what is here? Actually here that means here Ki is reacting with H2H2O8, and there will be formation of I2 and K2SO4, like that. This one meaning here, but in the examination question may ask indirectly here. So in this reaction, the requirement of temperature will be very high, and for this reaction, when without catalyst, the requirement of temperature will be very high. But if the catalyst, compounds of iron will be taken, Fe3 plus, like Fe2O3, Fe3, like this compound, when taken, then the requirement of temperature will be very less. How does that happen? So Fe3 plus firstly react with, the Fe3 plus will firstly react with iodide ion, and there will be this Fe3 plus will reduce into Fe2 plus, and oxidize the iodide into iodine, I2. How's the oxidation number of iodine here is 0. Oxidation number of Fe, iron, has been decreased from +3 to +2. And the oxidation number of iodine has been here, I minus changed to 0. So minus 1 to 0. So there is increment in oxidation number. So that's why I minus get oxidized and Fe3 plus get reduced. Okay. With this now Fe2 plus form, this Fe2 plus again react with persulfate ion. This Fe2 plus means ferrous ion again react with persulfate ion. As a result, sulfate ion will form and Fe3 plus that get regenerate. So overall reaction will be what? What will be the overall reaction? You may goes on that one also. So overall reaction here, 2 Fe2 plus there was and 2 Fe3 plus. This can cancel out. So here and 2 Fe3 plus and 2 Fe3 plus. That means what has been used? That has been evolved also. So reaction here is S2O8 2 minus. That's react with I minus 2 moles of I minus. React with persulfate ion S2O8 2 minus, and as a result there is formation of I2 and 2 moles of SO4 2 minus. Same reaction here. So you write that, right? You write the reaction as 2I minus react with persulfate ion S2O8 2 minus in presence of Fe3 plus. And then after there will be formation of I2 and sulfate ion SO4 2 minus. How much? 2 moles of sulfate ion. This forms. So that's the reason here. So never say that the catalyst don't participate in the reaction. Catalyst participate in the reaction, and due to their participation, the value of activation energy decreases. The catalyst react with any one of the reactant, and D block elements shows catalytic behavior. Why? Because in case of D block elements, there is incomplete d orbital. Like here, Fe3 plus contain incomplete d orbital. That's why it do temporarily bond formation with any one of the reactant, and as a result, the value of activation energy decreases. The value of activation energy decreases, and hence, at low temperature also the reaction proceeds, and at higher temperature or at the constant temperature, when catalyst will be taken, then the rate of reaction will increase. As you know, for every 10 degrees Celsius rise in temperature, the rate of reaction becomes double. So here, this one overall reaction, this one was here. In the examination, question will ask why the D block element shows catalytic behavior. So you will have to write, since the D block elements contain incomplete d orbital, so it could do temporarily bond formation with a reactant, and during that course the value of activation energy will decrease. Therefore the rate of reaction increases, and therefore the rate of reaction increases. Clear? So D block element shows catalytic properties also due to presence of incomplete d orbital. Earlier we have discussed about what? Why the transition metals show complex compound formation. So that was also due to presence of incomplete d orbital, and the transition metals shows catalytic properties also due to presence of incomplete d orbital. Next one is formation of interstitial compounds. Okay, this one, and this topic is important for you for the 12th board examination as well as for the NEET examination. Formation of interstitial compounds. What actually is interstitial compounds? So like that here, suppose any transition metals you have taken, like scandium here. So in the scandium, that will be here, the cation will be arranged like this. In this one, this empty space, that is called voids. This vacant space, that is called voids. This one also is voids. in these voids or in this empty space, the small atoms like hydrogen, carbon, etc., they get embedded. They get embedded. Like carbon here. And then after bond formation takes place. Suppose here carbon bond formation takes place. So these compounds is called interstitial compounds. Okay, this compounds is called interstitial compounds because in the voids of the transition metals, the small sized non-metals get embedded, and then after bond formation takes place between the transition metals and the small sized anion. That compound is called interstitial compounds. And here is some example of that interstitial compounds about which we will discuss here. They have high melting points, higher than those of pure metals. Here, can you say why that happened? Why the interstitial compounds are hard and they possess higher melting points. So here, bond formation it is taking place. So bond will become strong. In the case of interstitial compounds, in addition to the bonding, metallic bonding, there will be covalent bonding between the metals, transition metals, and the small sized anion. That's why melting point will increase. Clear? So the melting point of transition metals is greater. Why greater? This one I have told you. In the examination, question will not ask you write the reason, but question will ask which of the following statement is correct. And among that, you should keep in the mind that the interstitial compounds have greater melting point. They are harder also because this void has been occupied. Same here, they are hard. Obviously, some borides approach diamond hardness. You know already. They are hard because this void got occupied by the anions. They retain metallic conductivity. Obviously, the anions got embedded in these voids, but it has not affected the free electron. So metallic conductivity will retain there. As for example, your steel is also good conductor of electricity. Steel is not bad conductor of electricity. Iron, good conductor of electricity. And when steel you form, then also that is a good conductor of electricity. So they retain metallic characteristic. They are chemically inert. So you already know if pure steel will be there, then that will be most probably that will be inert here. Alloys are also inert because chemical bond formation has been already taken place. As for example, in the Mahroli, there is an iron rod at Mahroli of Delhi. There is an iron rod which is built from the Gupta period. In the history, if you have studied, that was built during the Gupta period. So their time duration is more than that of the medieval period also. So you may realize that is of the ancient time. Not I am telling that ancient of the Mahabharata or the Ramayana period, but that's a time duration. That means near about 300 BC that was formed. So total how much period here? It's 2025. So the total time period will be 2025. So you may imagine how much old that is. That is an alloy. And you might have heard the Howrah Bridge, which was built by the Englishman. That is also the alloys which are very inert. So that was inert. So much raining, so much heat energy, that's passage. But even though no rusting of that Howrah Bridge has been taken place. So that is here the alloy or the interstitial compounds, they are chemically inert. Okay, alloy formation here. How is that alloy? Alloy may be considered as the mixture of two metals. That is called alloys. Interstitial compounds, there was non-metals, a small sized non-metals was getting embedded in the voids of D block elements. That was interstitial compounds. Alloy it will be the mixture of two metals. That will be called alloys. As for example, here brass is an alloy and bronze is an alloy. What happened? the atomic size of copper and zinc is approximately same. So when copper and zinc both will drawn in the vessels after melting them, melt the copper and melt the zinc and draw in a vessel. So during that course, what happened? Initially in copper there was only copper atoms, in zinc there was only zinc atom, but once their atomic size is same, so what happens? Some places here copper, here zinc, copper, zinc, or here zinc, copper, like that. So brass, this one here. So alloy formation is that much. The metals having approximately same atomic radii, they mix together and forms the alloys. As for example, brass is the alloy of copper and zinc, and bronze is the alloy of copper and tin. About this one, the alloy like brass is the alloy of copper and zinc or copper and bronze. That has been asked in a number of times, not only in your 12th board examination, that has not asked, but that has been asked in a number of competitive examination, include of the PCS examination. PCS, that is called Provincial Civil Service. That means State Civil Service, you may also say that. Provincial Civil Service or state, that means civil service of a state level. This question was asked in a number of times. So its importance of asking this one is more in CUET. Till now it has not asked, but nowadays MCQ question is asking in the 12th board examination. So that will be also important for your 12th board examination. So this point is important for you for the 12th board examination, once for the CUET examination, and if you will study, so that will be helpful for you when you will appear in PCS examination. So that was alloy. Alloy is what? The mixture of two metals having same atomic radii. That is called alloy. Now let's see some important compounds of transition elements. Okay, in that one we will have to discuss about potassium dichromate and potassium permanganate. That will be in the next video. For this video, in this video, it's all. Thank you, Team Educate.